Hi there, welcome to the first video on validity. Validity is really important because it's going to be one of the main things you've got to think about when you plan your study for your assignments in the Unit 5 module and also the Unit 26 because as we know they're combined. Okay. The definition of validity is the degree to which a test or instrument measures what it purports to measure and can be categorized as logical, content, criterion or construct validity. That reference comes from Thomas Nelson and Silverman 2005 where all this information has come from. Okay, the book is called Research Methods in Physical Activity. Really good book, especially to use when you are starting and learn about research methods. Essentially the question to ask yourself when thinking about validity is, does my test what I want to measure? And the example that I've used here is, if I wanted to measure upper body flexibility, would the sit and reach box be valid? Okay, that isn't a valid measure because the sit and reach box would test my hamstring and lower back flexibility and not my upper body flexibility. There's different types of validity. The first one is logical validity. Again, the definitions come from the same book, and the definition is sometimes referred to as face validity and is the degree to which a measure obviously involves the performance being measured. The example given is the static balance test. Okay, the static balance test obviously involves static balancing and therefore would be said to have good logical validity because the description of the test is almost in the name. Now this type of validity is seldomly used by researchers because it's not objective enough. It doesn't give us enough to think about. It doesn't give us enough to measure. Content validity then. This is the degree to which a test adequately samples what was covered in the course. Okay, this type of validity is usually used in education scenarios. Okay, the example given is, did the exam that was taken by the students cover all of the anatomy topics that they had learned? Okay, so think about your CYQ that you're going to be doing this year. You would be expecting that that exam would cover all the topics you get taught in that lesson. If it didn't, then that exam would be said to have low content validity. Okay. Similar to logical validity, there's no statistical evidence that can be produced for content validity, and again, it's something that in terms of sports science research wouldn't be used all that much. Criterion validity then. This is split into two different categories. Okay, we've got concurrent validity, which we've kind of touched on before in another lesson. Okay, its definition is the type of criterion validity in which a measuring instrument is correlated with some criterion that is administered concurrently or about the same time. So one of the examples I've used in lessons is performing gas analysis versus Cooper run calculations, trying to figure out how much oxygen someone uses during exercise or their VO2 max. Okay, to find concurrent validity, I would take a group of students or learners and perform the gas analysis alongside the Cooper run estimations to figure out whether the two tests gave me the same results. If they did, then we could say the Cooper run test would have good concurrent validity. The other type of criterion validity is predictive validity, and this is the degree to which scores of predictive variables can accurately predict criterion scores. Okay, and the example given is predicting scores based on initial assessments. So if you can think about maybe it's at school when you're doing your GCSEs and all the little tests that you did when you're running up to your final exams, you got an estimated mark that you would get. Maybe you estimated a B or a C. Okay, that's the same sort of thing, and it's to the extent to what these initial assessments, how good they were at predicting your final grade. If they were good at predicting your final grade, then they would be said to have good predictive validity. Okay. The final two that I want to touch on is one's constructive validity, the degree to which a test measures a hypothetical construct, usually established by relating the test results to some behaviours. Okay, so the example would be a person with a high level of sportsmanship. Okay, you would expect them to have a certain behaviour when playing their sport. So you expect them to behave in a certain way. Say, for example, like complimenting their opponent on a good shot. Okay, not cheating, following the rules, and all round being a good person to play against. Okay, on the opposite side of that, if you expected someone who had a low level of sportsmanship, you'd expect them to cheat a lot. You'd expect them to break the rules. you'd expect them to have a bad attitude towards their opponents. Okay, so it's all about thinking about how hypothetical the situation is. Okay, and can you predict behaviors based on what you think will happen in your test or experiment. The final one, and potentially the most important one that you're going to have to think about when planning your study, is ecological validity. And we definitely talked about this in the previous lesson, okay? And it's to the extent to which a study's methods, materials, and settings approximate real-world settings, okay? So there's lots and lots of research being done with footballers in particular, where the footballers have been placed on treadmills, okay? And it kind of goes back to the argument we had last year in year one, based around laboratory versus field-based testing, okay? Does making a football run on a treadmill really represent them running on a football pitch, okay? It doesn't really, does it? Because there's no grass, there's no weather conditions. They can only run forwards, they can't do the sideways movements and the backwards running, which they'd expect to perform during football. So does having someone run on a treadmill have good ecological validity? No. But at the same time, there's obviously the pros and cons of laboratory versus field-based testing. Having them in the lab, you can control the environment better than you can if you're on the field. Okay, that's everything for validity. I'm hoping you've wrote all of them definitions down because you'll need them for your exam or your little mini test for assessment for learning for your learning objective 1, which you'll take once you've watched the reliability video.